right, so 121, that's a coefficient. It's a regular number, right? So we're going to first start by checking it in the home screen of the calculator. So second, x squared, 121. If you get a whole number, then that whole number is your answer. You are done. So the answer is 11. It is not the square root of 11. Oftentimes I have kids do that, right? But like, think about how much that doesn't make sense. The square root of 121 equals the square root of 11. It's like you telling me 100 equals 10, right? Like, doesn't make sense. They can't equal each other. So the square root of 121 equals just regular 11, not square root of 11. All right? So number 320. So that is another coefficient. So I'm checking it here. I've got this long decimal. Where do I go if I get a long decimal like that? What would be the next button I hit? Y equals. So I'm going to do 320, not the square root of 320, divided by x. And I'm going to look down this column. And what I'm looking for is a perfect square. When you square a number, you're taking it to the second power. So I'm looking in the x squared column for a number in the y1 column. What number did you end up picking for this one? What's my perfect square? Nate? 64. Next to 64 is a 5, so I need to use that as well. So I've got root 64 and root 5, right? The two numbers that were next to each other. And then I'm going to check each of them out. So the square root of 64 and the square root of 5. The square root of 64 becomes 8. And 8 is nicer to write than the square root of 64. So I'm going to change that. The square root of 5 becomes this long decimal. Square root of 5 is nicer to write than that long decimal. So I'm going to keep the part that's nicer. Okay, so I'm going to change the 64 to an 8, but I'm going to keep the root 5. So my final answer is 8 root 5. We talked about yesterday how we can always check this work by doing the square root of 320 and seeing what that is as a decimal, and 8 square root 5 and seeing what that is as a decimal. If you're right, those decimals will match. So just a quick way to check your work. Takes less than 30 seconds to do it. All right, this is an exponent. Exponents always behave differently than coefficients. So with the exponents, you're kind of going to pretend like there's a little 2 out here and treat this like a division house. You're just dividing by 2. 2 because it's a square root. Okay, today we're going to change that. We're going to make it a third root and a fourth root, and we're going to divide by different numbers. But when there's no number out there, let's imagine that it's a 2. So I'm going to do this inside number 24, this exponent divided by 2. If it's even, that division works out perfectly, and you'll just drop the root. So the square root of x to the 24th is just x to the 12th. If you want to check that, you can't check it in the home screen of your calculator, but you can check it here. So I can do the square root of x to the 24th in y1, and then in y2, x to the 12th. And if I'm right, my table will match on all of the values. You can see side by side, everything matches. So just test taking strategy to check your work there. If the exponent is odd, though, we'll have to do what we did here, right? So 121 is a perfect square. It was pretty quick. 24 is also a perfect square. It's pretty quick. When it's not a perfect square, like number 2 and 4, you have to split it up. This first exponent will be the highest even number below 33. What's that? 32. And then the second exponent will be a 1. So that together, that's still 33. And then for this one, I'm going to divide by 2. So 2 goes into 32 perfectly 16 times. So the root goes away. For the 1, I'm going to leave that as is. And I'm not going to write the 1, but you can. We talked about yesterday how I'm not going to mark you wrong if you write the 1. You just don't do it. Again, I could put this in y1 and y2 and check my answer if I wanted to. Everybody okay with those so far? Review from yesterday. All right, number 5. It's just important for you to recognize that what you do to the 27 is not what you do to the x to the 10th. is not what you do to the y to the fifth. So sometimes it helps to just kind of write them all separately. You don't have to do that, but separating them kind of separates that mentality. 27 ends up not being a perfect square, and if you type it into your y equals screen, you should pick 9 and 3, and ultimately that reduces to 3 root 3. Just the same way we did number 2. 10 is even, so just like number 3, I'm going to divide it by 2 and drop the root. So the square root of x to the 10th is just x to the 5th. And then finally, 5 is not even, so just like I separated number 4, I'm going to separate this into 4 and 1. Still adds to 5, but now I've got an even number that I can divide by 2. 2 goes into 4 perfectly twice, so I can drop the root. And then the 1, I'm going to keep. Your final answer, though, needs to be reformatted. So I need to take these terms that came out of the root, and I need to write them together. And then the terms that are in the root, I'm going to write them together. So the final answer for this one is 3x to the 5th, y to the 2nd, root 3y. All right, what about 343? What perfect square went into 343? 49. What was next to it? All right, so we've got root 49, root 7, or 7 root 7. I've got a square root of x. No exponent. What can I put? A 1. All right. Now, if I go to split this up, I'm going to split it up into 0 and 1, which is going to put me right back to where I started again. So I'm just going to leave it. There's nothing I can do to an x to the 1. It's just going to stay as is, and it's going to carry through to the final answer. I can't break it up, and I can't divide it by 2. All right, and then y to the 7th will become y to the 6th, and y to the 1, which is y to the 3rd, y to the 1. And so if we reorder all of this, we'd end up with 7y to the 3rd root 7xy. Do you guys feel kind of good about that? Because we're going to use those concepts in today's class. All right. Today we're going to get away from square roots, and we're going to do 3rd roots, 4th roots, 5th roots, 6th roots, 7th root, all the way up to 8 roots. Okay. Obviously that goes on forever, but the list had to stop somewhere. And the numbers get really, really, really big once you get to 9th roots, 10th roots. So we stopped at 8. And today we're just going to learn how to simplify them. It's really not much different than what we did yesterday. We're going to do that with regular numbers, coefficients, and we're going to do that with variables too. And we're going to do that in our toolkits and our workbook, so you'll need both of those copies now. So this is on page 2. Really similar notes to what you did yesterday with a minor twist. That's why I tried to put less blanks, because we already took these notes yesterday. It says, check to see if it's a perfect power in the home screen using. Now this is different. A square root you can hit second x squared, but a 3rd root you can't. Second x squared is going to give you a square root. So to get a 3rd root, a 4th root, a 5th root, we're going to hit math 5, I believe. Let me just check to make sure I'm not lying to you. Yes, math 5. Now for all of us that might, well for half of us that might look different on your calculator, depending on the version of the calculator you have. So I'm going to show you what that looks like for both versions when we go do an example, okay? But math 5 for all of us is the same button we choose. It's just the way it looks might look different. Okay, once we hit math 5, if we get a whole number, we're done. So very similar to the first step of a square root. It's just we're using different buttons to get there if it's a different type of root. Okay? If you get a decimal, move on to step 2. Step 2 is not any different, so I don't have any fill in the blanks, right? Step 2 is going to be go to your y equals screen, do the number divided by x. That's not different than you did yesterday. Step 3, look through the Y1 column of the table, starting with the original number and working your way down. You are looking for the biggest perfect power. That's not different, but it's kind of different. What makes it different is you're not going to be looking at the same column you were looking at yesterday, right? So if you're doing a third root, you'll look at the x to the third column. If you're doing a fourth root, you'll look at the x to the fourth column. So it's different in where you're looking. It's not different in that you're looking for the biggest number. It's just you're really used to perfect squares. You probably know them in your head. My guess is no one in here knows all of the perfect threes, right? So we have this toolkit, we can use it, all right? Once we have that, you'll see everything's the same. Take the number from step 3, write it next to the number in the table. Type them both into the home screen of your calculator, change the one that's the whole number, keep the one that's the decimal. All of this is the same. Okay, the process is not different except for 2 things. We're using a different button in the calculator and we're using a different list of numbers. Everything else, the mentality of it all, is the same. So I don't think you're going to think it's too hard, all right? So, example 1, we want to type in the 4th root of 625. Notice there's a 4 out there. It's not a square root. We can't hit second x squared. That's the square root of 625. So to get the 4th root, you're going to hit math 5. Now, depending on the type of calculator you have, it is going to look different. So I need you all to have your calculator out and you need to be physically trying this so you can see what your version of the calculator looks like when you hit math 5. So for this calculator here, when I hit math 5, I get something like this. For some of you, if you have something typed in your calculator, it might even say like A and S in that little top box. We can change that, all right? That number is your root number. So for this problem, I want that to be a 4. So just like arrow over to that and change it to a 4. And then the number inside is 625. Is there anybody in here whose calculator does not look like that when you hit math 5? I need to know, because I can't help you if it doesn't. Anybody's calculator will not look like that when you hit math 5. I'm going to show the other way, because maybe you don't know that yours doesn't look like that. All right, so this is one way to do it. I get a whole number, I'm done. So the 4th root of 625 is just 5. I don't have to do anything more with that. Your calculator also might look like this. This is just like an older version of the calculator. When I hit math 5, if I get this, if you have a calculator that looks like this, you have to type the 4, the little number, before you hit math 5, right? So I need the 4 to be in front of this. And then I hit math 5, and then I do 625. What this version of the calculator does is it picks the 4 up and puts it in for x. But you have to tell it, like you have to put it first to tell it to do that. Otherwise, you're not going to get the same answer, but you do this way. So just depending on the type of calculator you have, it's going to affect how you enter that. All right, so 2 different ways to do it. It seems like all of you had this version, but maybe you didn't. So I'm going to stick to this one. All right, so we do math 5. I want this to be a 4. I want this to be a 625. If you get a whole number, you're done. So the answer to the first problem is just 5. It is a perfect 4th. For the second one, it's a 3rd root of 375. So I need the number on the outside to be a 3 now, not a 4. So I want it to look like this. So if I'm typing this into my calculator, I'm doing a math 5. And that number on the outside, whether your calculator defaults it to something or not, you want to arrow over and you want to change it to a 3. And then 375 is going to be in the inside. When you get a decimal, just like you would for a square root, you go to the y equals screen. Okay? The key here is just making sure you're not using second x squared, because we're no longer looking at a square root here. All right? So I'm going to go to the y equals screen, and just like I would for any other problem, I'm going to do a 375 divided by x. But remember, this is a 3rd root. So when I look at my table for this one, I want to be looking at my x to the 3rd numbers on my paper. I'm not going to do 1. 1 is not special, so I'm going to skip that one. That's 8, 27, 64, 125, 216. I'm not going to go past 343 because it's definitely not going to be anything above the actual number itself, right? So I am looking for one of those numbers. They are different than perfect square numbers. And the reason that I picked x to the third is because this is a 3, right? If it was x to the fourth, I would use the other column on the paper. So I'm looking in my table for one of those numbers. And I'm going to start on 375, and I'm going to make my way down. So 375, not on the list. 343 was. Decimals aren't on the list. Do you see how 125 is on the x to the third list? So I'm going to use the 125, and I'm going to use the number next to it as well. 125 is on the x to the third list, so I'm going to use 3 as well. When I write this, when I write it in 2 roots, this is not right. That is the square root of 125. I am working now with third roots. You have to remember to include that number or it completely changes the value of the problem, okay? So if there's a little 3 on the outside of the root, you gotta write the 3. Everybody okay with that so far? All right, now that I do that, I'm gonna do the same next steps. It's just I'm not hitting second x squared to check these next steps. I'm doing math 5. So it was the third root of 125. That one's a whole number. And then the other number that I'm checking is 3. So I'm going to do another math 5, third root of 3. You can see that 1 changes to a whole number. This is a lot nicer to write than that. So I'm going to change this to that. This is not nicer to write. I'm going to keep this one the same. So my final answer here would be 5, third root of 3. I can check my answer just like I checked the other answers in the home screen of my calculator. Just got to make sure you're using a third root and not a square root. So math 5, the third root of 375. And I think that's the same as 5, math 5, 5 times. I think you have to put a times or else it defaults that 5 into the box. So 5 times math 5, the third root of 3. So you can see for this one a little different. I had to add this times. If you don't, the 5 filters in and it makes it a 5th root. Okay, so it's 5 times the third root of 3, and you can see they match. So we can still check our answers using our calculator. All right, let's try another one. The 6th root of 1458. So in my home screen of my calculator, I'm going to do a math 5, the 6th root of 1458. Or if you have the classic and you don't realize it, right? I'm going to do my 6 first, and then I'll math 5. Oops. Okay, so if you have that version of the calculator, you just type the 6 in first, just depending on what calculator you have. Either way, we're getting a decimal here. If you get a whole number, you're done. If you get a decimal, you've got to go to the y equals screen. So I'm doing 1458 divided by x. Now, what am I comparing this to? This is an x to the 6th. So this is a 6th root. So I want to look at my x to the 6th list. This is 64 and 729. It's not going to be 4,096 because that's bigger than the actual number. That one's not going to be divisible by it. So I'm looking for one of those 2 numbers in my list. And I'm getting those numbers because this is a 6th root. I want to look at the 6th list. So let's see what we've got. I see the 729, yes? So 729, and next to the 729 is a 2. So what this looks like when we write it out, the 6th root of 729, and the 6th root of 2. If you don't want to type that into the home screen of your calculator, another way to simplify the 729 is go to the 6 column, put your finger on the 729, and then slide your finger all the way over to what x equals. That's what it will reduce to. Does that make sense? So if I don't want to math 5 that and figure out what the 6th root of 729 is, I go to the 6 list, put my finger on 729, slide it over, I can see that x equals 3. So this is going to simplify to 3. Just an alternative if you want to avoid the calculator. Okay, you don't have to, you'll have the calculator, but it's just another way to get the 3. You could just as easily do and get the 3 that way. So whatever you feel more comfortable with. The second one's going to be a decimal, so I'm just going to keep that the same. Sometimes I have kids get confused and they want to like divide those numbers, but it's not an exponent. So I'm not doing any division here. It's just, does it simplify or does it not? Okay with that? All right, so we're going to take a quick pause and have you try to. All right, so you're going to try D and E. For D, you're looking at the 7th column, because it's an x to the 7th. For E, you're looking at the 3rd column, because it's x to the 3rd. All right, so if you type this into your calculator, the first one, do you get a whole number? What's the whole number? All right, if you don't want to type it into your calculator, go here, right? This is a 7. Go to the x to the 7th column. You see a 128, which means, oh, it is a perfect 7. Take your finger, move all the way over. 2, right? Another way to get 2. So this one is just 2, and we move on, okay? This one is not a perfect root, which means I'm going to need to split it up. Which 3rd did you pick? And what was next to 64, Nate? Now, the square root of 64 is 8, and sometimes I have kids want to write that as an 8. But it's not a square root anymore. It's a 3rd root. So I need to find the 64 in the x to the 3rd column, not the x to the 2nd column. So the 3rd root of 64 is 4. Or type it in the calculator and get the 4 that way. This is not 8, it's 4. That's the only confusing part I think about this, is that you're just looking at sometimes the same numbers but getting different outcomes. All right? And then this will stay the same. If I wanted to check this, just to show you one more time, I'm going to do math 5. I'm going to do the 3rd root of 320. And then I'm going to do 4. I've got to do times before I type this next part. And it's the 3rd root of 5. Right? So just don't forget that time step, or it's going to filter the number into this little part of the root. it'll make it a fourth root instead of a third root. All right, so now that you've seen a few of these, I just want to give you a little bit of time to practice. We'll do this the same way that we did yesterday. So if you want to work with someone, you can. If you want to work on your own, you can. If you're really struggling and you want to work with me, you can. Okay, so just let me know. If you want to work with me, I'm happy to sit with you. We can do it at my desk. I'm going to go over the answers in, let's go less than 10 minutes so I have time to get through the notes. So let's go 6 minutes, a minute, a problem. So at 8:16, we're going to move on. This is in your workbook. It's on page 6. If you need help on any, let me know. All right, 8:16, we're moving on. All right, so here are the answers. They're all up there. The first two, I just typed them in, got a whole number, moved on. The last four, I had to do a little bit of work for them. So just kind of take a peek at what perfect numbers I picked and how I simplified them, and let me know if you have any questions on any of them. You've got to make sure you write the little number on the outside, though. That's a habit that you're just going to have to get in the routine of doing, right? So we're so used to not having a number out there. What do we think? I didn't lie to you, right? It's really not that bad. If you can do a square root, you can do a sixth root, okay? Especially if you don't have to memorize what the perfect six are, right? You have this list. You're able to use it on all your quizzes and tests. All right, so second half of class here, we're going to do the variables. Again, the same as we do for square roots, right? With square roots, we're dividing by 2. For six roots, we're going to be dividing by 6, okay? So really, you're just doing division. The only difference between a variable with a square root and a variable with an x to the 5th root is, with a square root, your second number is always 1. With a third, fourth, fifth root, it might not be 1, right? So that second number is going to be a little bit more work, but if you know how to add and subtract, you're going to be fine, okay? So in your toolkit, this is on page 2. So I've got the blanks kind of filled in for you. You're just going to fill those in, and then we're going to do these examples down here. So it says on page 2, divide the exponent by your root number. The root number is that little number on the outside. The real word for the root number is called the index. But what I felt like is the last thing you need is another vocabulary word, right? So instead of saying index, I'm just saying root number. I think you'll know what that means. So if we take that inside number and we divide it by that outside number and we get a whole number, you don't have to do anything else. It's like when you have an even number and you can just divide by 2, right? But if the inside number does not divide nicely by the outside number, you've got to do a little bit more. So it says split the exponent into the highest multiple of your root number. And that's just going to depend. With even numbers, that's 2, 4, 6, 8, 10, 12. With a third root, that's 3, 6, 9, 12, 15. With the fourth root, that's 4, 8, 12, 16. It just depends on what the number is. The second number, this is where it gets different. With a square root, the second number is always 1. But with any other root, it's going to be the difference between your number and the multiple you chose. Right? I want the two numbers to add up to the exponent. I got to make sure they do that. So you're going to have to do a little bit of subtraction to get that number. And then the last part is just simplify the one you can and keep the one you can't under the root. The one you can't is not necessarily going to be a 1. It might be a 1, but it might not be. Right? Hopefully this makes more sense when you see it in examples here. I'm going to separate this idea, right? Because what I'm going to do to the 256 in this first example is not what I'm going to do to the x to the 32. Variables work different than coefficients. So for that 256, I'm going to math 5 it. What type of root was it? What was the number on the outside? 8. The 8 root of 256. Perfect whole number. It's a 2, so I'm just going to write 2. Now, for exponents, you're going to take, I want you to just think inside divided by outside. You're going to take the inside number, 32, and divide it by the outside number, 8. If you get a whole number in that division, you don't have to do anything more. You'll just divide and drop the root. So inside number divided by outside number. Right? That's what I'm doing in terms of the math. That's a really nice division problem, right? I get 4 perfectly. So this is just x to the 4th. I don't need the root when it divides nicely. So my answer is 2x to the 4th. There's my question. Here's my answer, right? If this is correct, the table matches up for everything. So again, you can still check these in your calculator. You just have to know where to check them in your calculator. All right, so for the next one, let's split this up. We're going to look at the 6th root of 192 and the 6th root of x to the 45th. So 6th root of 192. I'm going to math 5, the 6th root of 192, decimal. Y equals 192 divided by x. Now I'm looking for a perfect 6. 64 is showing up for me, right? So 64 and 3. Perfect 6 because this is a 6th root. So it's 64 and then next to it is a 3. I'm going to use my paper instead of my calculator for the 64. So in the x to the 3rd column, I'm putting my finger on the 64, and I'm going all the way over to see that x equals, oh, I'm in the wrong one. In the x to the 6th column, I'm putting my finger on the 64 and going all the way over to see that x equals 2. You can also put this in your calculator. I'm not going to do inside divided by outside because this is a coefficient, it's not a variable. This is done. Nothing I can do here. Over here, I want to do 45 divided by 6. But I can't because that's a decimal. All right? So now I have to think about multiples of 6. I want to split this up into something that divides nicely into 6. Things that divide nicely into 6 are called multiples of 6. They are 6, and then 6 plus 6 is 12, plus another 6 is 18, plus another 6 is 24, plus another 6 is 30, plus another 6 is 36, plus another 6 is 42, plus another 6 is 48, and so on, right? So I want to look at that list of multiples of 6, and I want to pick one that's below 45. There's a lot of them below 45. You want to pick the highest one below 45. Make sense? I'm going to pick 42, right? So this is going to be 42, and then the next one is going to be 45 minus 42. I need that to add to 45 still. So this next one's going to be a 3. Does that make sense? The next one's always 1 with a square root, but it's not going to be a 1 here. I need them to add to 45. If I have a 42, then this is going to have to be a 3. So now they add to 45. All right, this one I can divide nicely. The inside number, 42, divided by the outside number, 6, is a perfect 7. So that's x to the 7th. I don't need the root anymore. Here, the inside number 3 divided by the outside number 6 does not simplify. It is a decimal. So I'm just going to leave it as is. If your inside number is smaller than your outside number, you're done. You don't have to do anything else, okay? Just a way to check your work. If the inside number's smaller, there's nothing more that you can do. My final step here is just gonna be to reorder. So I'm gonna take these and I'm gonna write them together, and then these, and I'm gonna write them together. So it's gonna be 2x to the 7th, 6th root of 3x to the 3rd. I'm not gonna check this in the calculator, but I could. All right, so just to save time, I'm not gonna go and do that. All right, one more. Now I'm looking at 4th root of 405, 4th root of x to the 23, 4th root of y to the 3rd. Let's start with the 405. I'm going to math 5 it, and it's a decimal, so I'm going to go to the y equal screen. 405 divided by x, and I am looking for a perfect 4 because it's x to the 4th, so 1681, 256, 625. Do we see any of those? 81. Next to 81 is a 5. Right, so I pick those. Now to check those. The 4th root of 81 and the 4th root of 5. One simplifies, one doesn't. So I'm going to change the 81 to a 3. I'm going to keep the 5 the same. That's first half of class stuff. Now, 4th root of x to the 23rd. Can I do 23 divided by 4 and get a nice clean number? No. So now I have to think multiples of 4, because now it's a 4 I'm looking at. 4 plus another 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 4, and so on. I want to pick something under 23, preferably the highest something under 23, which is 20. My first exponent is going to be 20. So what will my second one be? 3. Remember, the magic number here is 23. If one of the numbers is 20, the other number has to be 3. They still have to add together to be 23. I don't want to lose that value. It's not always a 3. Okay? It just has to add together to be that number. It could be a 1. Okay? It could be a 2. In this case, it's a 3. So, inside number 20 divided by outside number 4 is x to the 5th. When it divides nice and cleanly, the root goes away. Inside number is smaller than outside number. That's a good sign to tell me I'm done with this one. Y to the 3rd does not divide nicely into 4. I can't split it up either though, right? Because if I'm looking up here at my multiple list, none of those multiples are smaller than that. If the inside number is smaller than the outside number, you are done. There is nothing more that you can do. Leave it as is. I'm not changing it. If the inside number's smaller than the outside number, you're done. Don't do anything to it. Leave it alone. So finally, rearranging my answers. I'm putting roots with roots with roots and numbers that aren't with roots. So 3x to the 5th, 4th root of 5x to the 3rd, y to the 3rd. I feel like it looks so much harder and so much more studious than it actually is, right? It's not too difficult, but it sure looks it. It looks like you're doing some really high-level math here, so own that part. All right, so we're gonna finish with you trying these two. All right, this is the last thing we're gonna do today. You are trying these. I'm not gonna go over them. I'm just gonna post the answer for time's sake, so that it gives you enough time to try it. And then I won't talk about it crazy. I'll just post the answer. So see what you can do for these two. And then before you pack up, I want to go over the answers. Sure. Right, so we'll learn that eventually, but it's technically not in simplified radical form if it has a fraction in it. What that's called is simplified exponential form, which we will learn after spring break. But for now, you need to know how to keep it all in whole numbers. What's up? Sure. Okay, did you type it into the calculator?
Yeah.
And did you get a whole number?
Yeah.
And did you divide the inside number by the outside number?
No.
So with exponents, you gotta divide the inside number, 56, divided by the outside number, 7. If it works out nicely, which it does, you'll just write it. So for example, like the square root of x to the 4th, we just do 4 divided by 2. That's x squared. So you're doing 56 divided by 2.
Okay.
Okay?
Thank you.
Mm-hmm. For the first one, you should just be math 5ing the 128 and dividing the inside by the outside. You shouldn't have to do any work after that. Everything works out really nicely in the first one. Here's what I end up getting. 2x to the 8th. The 7th root of 128 is just the whole number 2. And 56 divided by 7 is the whole number 8. Put it all together, 2x to the 8th. The next one's going to take you a little bit more time. Got plenty of time. Just don't pack up your toolkit. I want to make sure that you know that your answer's right before you put it away. Okay, we still got 5 more minutes. I see some people are still working, so I don't want to post the answers quite yet. All right. I'm breaking the 1024 up into 5, 12, and 2. 5, 12 is my perfect third. So that's 8 third root 2. I'm breaking the x to the 29th up into 27 and 2. Stop me if that doesn't make sense. Multiples of 3 get me all the way up to 27. After that, it's 30, and that's too much. And 27 and 2 add up to 29. And that last one I can't simplify because the inside is smaller than the outside. It's already done. What do we think? Questions? We're doing it. All right? Tomorrow when you come in, we'll do an entrance slip and see where you're at, and we'll split up and we will practice. I promise you there are 0 new notes tomorrow. Nothing. We are just practicing this stuff. And then, unfortunately, Thursday and Friday is a link it day. Do you guys remember last semester when you had to do that brutal 50-question link it test where you knew basically nothing on it? Yeah, we got to do that again. Don't shoot the messenger. I'm just told we gotta do it, all right? So we'll do that Thursday, Friday. So tomorrow is our last day of the week. Let's consider it that way, all right?